Okay, I ran into a... Actually, I didn't really realize this because I didn't go outside when I was making this the other day. But I had... this is the factory battery hold down. As you can see, it just swims in there. So, this is a 24F, which these come with a 27F. But the tops, the widths of these should be the same. So... I was in the shop and I had the old battery out. This is already mounted in here. This is just temporarily. I'm getting new terminals and stuff. I just didn't get them yet. But the length of these that's the only thing that's different. The height and the width is supposed to be the same. So I was like, I mean, yeah, it'll work. You know what I'm saying? But I don't know. It's kind of... I just didn't like it. And so what happened is if you see this, there's a step here, right here. And so I'm making this part based on the height of this, and this step is, I don't know, it looks like it goes about down an inch. So this thing is not going to go down that far. But the battery is the same as the old battery. It's just when they put this cap on here, it's smaller. I don't know why they didn't. Why didn't they just make it square? Because then everything would have fit. But anyway, so I ended up making this part for it, which you'll see me make. And obviously, if you have one of these exact batteries, then you'd follow the dimensions I give. If you have one that's square at the top, you'd just add, I think it measures that. Let me use this tape measure here. Got a little bit to get in there. It's 6 3/4, but this battery is 6 3/8. Big difference. So I made the part is made for a 6 3/8. Now I allowed, you'll see several thousandths for coatings and whatnot on the part, but just FYI, any of those measurements are dependent on the top cap dimensions. Mine's 6 3/8. Now, like I said, I cut it wider than that to allow for coating. So, depending on what your coating is, my film build ended up being 15 thousandths. So, when you factor in here and here, it's going to shrink the cavity by 30 thousandths. So, it just fits on there, which I will get to showing you that. Now, here is the factory battery that came in the truck. It lasted a while, 12 years. So, and actually I just charged it up because I got to keep the core for some odd reason. Anyway, this battery, it doesn't have those steps. It's just squared off at the top. It has a step at the bottom, but the top is square. So it is 6 3/4. So it's exactly what the other case of the battery is, but the top. So if you buy one of those batteries, that top cap is smaller. I don't know if it's like it on the 27R. Probably is. It's just those are just longer this way. This way, the width and the height are the same. They should be, or the cases are, but the length of it's longer, which doesn't affect the hold down. But in this case, it does, the way they designed that battery. Anyway, just an FYI, just explaining why I did this. I didn't really notice it until now. It was cold out, and I just went out and measured it, and I was like, oh, okay, it's smaller. I didn't really investigate that had that step on there, so that's why these dimensions are the way they are. It's just for that specific brand battery, unless other ones have that step. So you'd have to measure yours and add or subtract accordingly to the numbers that I give. This piece is 8 3/4 inches long. It's a 1 1/4 inch piece of 6061. I'm going to put a trough in here. I don't know, I'm going to go down about, I think it was about 180 thousandths. And so there'll be an edge to catch the edge of the battery. And then I'm going to put some holes in it, you know, make it look better. And then the holes for the in the mounting bolts. So let me get to that. Here's my numbers so far. This where I'm going to cut this trough out here, I have it at 6.390 inches. The battery measures about, when I measured it was 6 3/8 across. I'm leaving about 7 thousandths on each side because I'm going to put a coating on here, and I want it to fit. 6 3/8 look like it would fit easily, so you know, I just want to leave a little bit extra. And then, which the movement on this, the DRO would be 5.890 because I'm using a 1/2 inch end mill. So you just add 0.500 to that, and then it comes up to 6.390. That's the measured distance, but on a DRO it would be 5.890. Uh, 6.390 inches between these two cuts. So this is where the battery top will fit. Okay, here's the math on this one. I wrote it down. I'm not a very good drawer, so this is the tangs that's not cut. It's these, not just this part. And then I leave a gap, so that'll catch the edge of the battery. Will be down in here, which is 320 thousandths before I start my first 3/4 inch hole. I'm gonna put 6 3/4 inch holes through here just to make it look better, I guess. And then, as you can see, that full cut is 6 and 390 thousandths. And then I didn't go through all these, but here you get the idea. The first edge of the hole is 320 thousandths in, and then the last edge of the hole is 320 thousandths in from the edge. So it'd be here, and then down there it leaves an edge to catch the battery. 3/4 inch hole, 1/4 inch space, 3/4 inch hole, 1/4 inch space, 3/4 inch hole, 1/4 inch space. These are all 1/4 inch spaces until you get down here, and then it's got a 320 thousandths space. That's because of the edge of the battery. I wanted to leave something. I actually was going to leave more than that, but it just worked out this way. I was going to leave a 1/2 inch, but I didn't. You know, it's just a battery hold down. I'm not going to go through putting all these fractions in here. So it's just something simple I could make, which nothing is usually simple, but this is the simplest thing I came up with pretty quick. And then here's the math on it. 6 holes 3/4, 4.5 inches, 1/4 inch space is 1250, and then it adds up to 5 3/4 of an inch. That entire cutout is 6.390. So that left me with 640 on just one end. I split that, and that's how I got 0.320 for each. I'm going to leave one for each edge. After you zero them out, then bring it over to 320 thousandths, and then you'd plunge it. And then you move it an inch each time. Inch from this first one, you move in 320 thousandths. It leaves that little shoulder there. Then from then on, you just move an inch. That way it leaves a 1/4 inch bridge in between each hole. And on the dials, you just move an inch every time after the 320. And then on the DRO, it would be these numbers, of course. Okay, I did off camera. I went ahead and I drilled all these holes to 1/2 inch, following that map I'd laid out. And I'm sitting back at 0.320. and I got a 3/4 inch end mill in there, and I just doused this with some aluminum tap magic. So let me go ahead and finish this. Which, you know, I can make them an inch, I could make them 15/16. Let me take a look at it and see what I think. Okay, now this is for the bolt, you know, the hold down bolt. It ended up being 6.820 on my DRO, or just go 1.5 inches if you're using dials after the 5320. Just 5320, screw them to another 1.5 inches, and you'll be at the same 6820. And it's a 1/4 inch hole. Okay, so this one's the same. So going from, you know, if you bring it back to the center of this hole, which is on a dial, was I had a plus 320 using the end mill. So it's 1.5 inches to there, which on the DRO would be a negative 1 inch 180 thousandths. I went ahead and chamfered these. I was just going to use a hand thing, but I have this, which this one's really not for aluminum, but I soaked it down with some tap magic because it's like, I think it's tin coated. It's not good for that, but it worked good just to take the edge off. I use the depth. I actually have a DRO on the depth, so I went ahead and chamfered those all the same, which I don't know what I started out with, but I just went ahead and did every one of them exactly the same on the Z-axis. So there it is. Okay, here it is done. Deburred all the holes, or these holes, and the edges, and I sanded the corners. So this is the underside, of course. I put deeper chamfers, as you saw. I just was doing that on the top. So I'll show you what it looks like on top of the battery. Now this is the old battery. It actually won't fit this one. This is the reason why I made it, because see, it won't fit. The battery's too, I don't know if you can see this, but see where that edge ends up? It's hooked on the other side. The new battery it's not as wide. So, but I mean, you could always flip it over if you ended up getting another one. Of course, it wouldn't have the edges, but it would still work. But I didn't make it for a 27F because I already have a hold down for that one. I made it for a 24F. So, but it'll fit on here. It fits between the caps. So, should look pretty good after I get the coating on it. I think I'm going to use maybe Plastisol spray. Or it's goes in the powder gun. Plastisol. It's real thick. It's a lot thicker than powder coat. Now I'm going to go ahead and do some. I actually decided I'm going to use this one. See, this is labeled Plastisol. It looks like powder coat, except it's kind of like those handles that are dipped in rubber that you see. Except, well, this one, the durometer, it's quite hard. It's not soft like that. I don't know if you can buy it soft like that or not. I don't know. I have some dips. That's the real stuff that they, you know, that they use in manufacturing, but it's gone hard. But this is powdered. But the thing is with this is you have to heat the part up, It's, you know, the directions for this one is you have to heat the part up to, like, you know, it says warm to hot. So then you put it on, and I guess might be too heavy for it the static to make it stick as well, because it's, you know, it's a heavier material. So you have to heat it up first, and then you put it on, and then you go ahead and you cook it, you watch it, you wait till it gets shiny, then it's done. Once it smooths out, it's shiny, it's done. It's not like powder. You go 20 minutes and 400 degrees. So we'll see how it works. I got the part in there heating up right now, so I'll pull it out and then I'll shoot it. Okay, there it's done there, if you can see. I'll go ahead and I'll cook it, and then I'll show it to you after it's done. Back side of it. Nice and thick. It's my little oven here. I don't know if you can see this stuff, but it's grainy. What you do is you wait until it melts. Once it's all melted, then you pull it. It's done. That's the difference between this and powder coat. This stuff will start to burn because it's, you know, it's like rubber. But it's pretty neat. I've only used it a couple other times. I usually powder coat everything, but I figured I'd try it on this. And if you can see that, but it's getting shiny now. Just waiting for I see a couple pieces of dust that haven't melted. They're just about ready to go. This stuff will burn, so you can't leave it in there forever. Figured since I was doing it, I'd go ahead and put another coat out, so I pulled it out hot and put it back over there and sprayed it one more time. And it's going to wait till it flows out. It says on there, you know, you can keep coating it till the desired thickness. So it's going to wait till it clears out one more time, or wets out, and then I'll be done with it. There it is, all wet. It's hard to see probably. Take it out. There it is out of the oven. It's super thick. It's nice. I'm glad I put 2 coats on it, so it's nice and smooth. Once it cools down, I'll show it to you. I don't remember if it gets dull or it stays shiny like that. I can't remember. So okay, here's the piece. It's all coated. I did a double coat on it, nice and smooth. It's nice. See, this stuff, it's hard. It's like I mean, I can just barely dig my nail in it. It's like a pretty hard plastic. And it ended up with a 15 thousandths film build by doing 2 coats. So I'm guessing it was like, you know, 7.5 thousandths per coat. You know, guess. But, you know, so yeah, 15 thousandths. So it actually shrunk this cavity by 30 thousandths, which I'm glad I left a lot. You know, I left a gap between there, because when I put this on, it just fits. I have to actually, it just has a resistance where I have to just push it on, which I'm sure it's fine. It's not much, but if you just used paint or just like a single layer of powder coat, you know, it'd be fine. You know, that would be the right dimensions. But this one, it's tight, which is fine. So okay, now, so when I went to put this on, of course, you know, I was checking these rods. Well, the factory mount has those drop downs on the edges, so you know, this actually is higher. So I measured them out, and here's what I'm going to do here is the back is going to be 8 1/4 to the bend, to this trough. And then I'm adding another inch for the bend I got to make. So 9 1/4, just out of this. I'm just using this threaded rod because that's what I have here. And for the front, 9 1/16 the J bend, add an inch for the J, so 10 62 thousandths, so 10 1/16 is the cut. So, and I'm just gonna bend them, and then I'm probably gonna coat them, I guess. Why stop now, right? Just keep doing crazy stuff. Oh, here, I'll show you this film build on here with my calipers. This is the piece I cut it off of. So it's that's about 381 thousandths. And then here is the part coated. 411. So added 30 thousandths of film build, so 15 per side. So it's nice and coated. So that should work good. I'll show you the fitment in a minute, or in a bit here after I'm done doing all the rest of this stuff. Okay, now I got it. I just got it in a mill vise because my other vise is, I'm restoring it, so I'm gonna have to make this do. A regular vise would be probably easier because it'd be up and down. You just put it right down through the jaws rather than the sideways stuff. So I have it sticking out an inch, as you can see, and then I'm just gonna go ahead and I'm gonna bend that over with I'm just gonna hit it with a hammer. Okay, so now it's like that. So what I'm gonna do here is I'm gonna pull it out a little bit here. This is just a 1/4 inch bolt. They aren't bent very much, so let's see. Hits and then I'm done. So I'm gonna have to cut this up. I made it a little bit longer than the other one because I knew I was gonna have to bend this, but it looks good. Looks like it's fine. Anyway, so let me measure the what it is now. To the J. Looks like it's 9 1/4, or no, let's see, 8 1/4 to the dip, to the trough, 8 1/4. Let me go look at the paper. Yeah, it's supposed to be 8 1/4, so that works. So if you want to try that, I don't know. I was trying to figure out something that would work real quick. So now I'm going to go ahead and do the other one. I'm not going to do that on camera, but get the idea. So when I made these, I made them so there would be, I think, 5/8 of an inch stick out over top of the clamp, and the nuts I'm using, they're like 200 thousandths wide. So, you know, plenty of room. Plus, if I'd ever have to flip that bracket over, if I got a replacement battery, because you could flip it over, it just wouldn't have the steps on it. I think it ended up what, maybe 200 thousandths thick. So I need that extra 200 thousandths of height for length. So if I ever have to flip it over, in case I get a different top battery, then it'll still fit. So I didn't want them sticking way out like the factory ones, but they're sticking out plenty enough that I could flip it over and still use it if I had to. But anyway, here is the here's both of them, and then here's the factory. See the little factory loop. I'm gonna go out and check them and see if I can use them the way they are. I'd kind of rather have them longer because we'll see. I'll go out and check them. Yeah, I think I'm just going to go ahead and cut them. The front one, you know, no problem. But the back one, it can be tight back there, so, you know, I had a hard time getting it in there. And it's really no point in leaving it long if you don't need to be. So, as you can see, these bends are identical. Using that 1/4 inch, this bolt, they put the perfect J on it. So yeah, I'm just going to cut them off to, yeah, basically the same length as the old ones. Okay, so I cut them off. They are a hair longer than the other ones. Maybe nothing. Once I clean them up, you know, probably exactly the same length. I also took the threads out of that trough there. Just ground a smooth spot. Okay, so those are done. Cleaned them up a little bit on the ends, the sander, and also tapered the ends and flattened them with a sander. So I get the bolts on, you gotta taper them a little bit. So those are all done. I don't know. I show this sometimes. I'm using this. It's just an Eastwood dual voltage power system. It has a switch. I actually keep it on high all the time. So yeah, I mean, it works. It's not a great powder coater gun, but it's good just for, you know, if you'd rather not paint. So I went ahead and I went and powder coated those nuts and washers and those rods real quick. Just a thin coat. That's good. That's what's good about it. You can put a real thin coat on there because it's not so powerful, and it doesn't screw up the threads really. So, you know, it's just I just rather use that than paint, because, you know, paint, you gotta let it dry. This stuff, you put it in the oven, 400 degrees, and, you know, 20 minutes later, take them out, let them cool down for 15 minutes. They're as good as they're gonna get. They're done. You can put everything together. There's all the parts powder coated, washers, nuts, hold downs. I'll go put it in the truck temporarily. I mean, I'm gonna put it in there, but I'm gonna have to pull it back out to when I change those terminal ends and flip that battery insulator around where it's supposed to be. Well, there it is. Light's not very good out here today, but this bolt ended up, I could have used about another 1/4, though it would work, because there's probably 3/8 sticking out of there, so even with this flipped over, it would still work. The back one's looks like about a 1/2 inch, so use them accordingly. But I'm not messing with it anymore. I think it looks good. I just snugged them down. I don't tighten these things down very tight. I don't want to crack the battery case like they do. Anyway, hope you like watching this. It's been a journey. Thanks for watching.